Hello, everyone. We'll wait a few minutes before we start. You can see folks are joining. Let's give it another minute before we start. Hello, everyone. We're going to give another minute. Okay, let's start. Hey, thanks for joining, everyone. My name is Rejith Krishnan. I'm the co-founder of Cloud Control. We have a platform that's AppZ, which enables DevSecOps and automated pipeline. Using our platform, our customers migrate workloads to cloud and manage them. So I have with me Amit Merchant. Amit, please introduce yourself.
Thank you, Rejith. Thank you for inviting me. So I've been in IT for 30 years. I spent my early years in microprocessors, then systems, and then cloud. And recently, I have started my own company in cloud automation. And I've also been a cloud consultant to CMSIT services. So CMSIT services is a pan-India company. It's a large company. We have big spread, nearly um, 22 different offices in different cities, 7,000 employees. We have 300 clients. And we've been primarily a data center company, but we are moving towards digital. We are moving into cloud. And so we thought this would be a good place for us to converge our interest with cloud control. Over
Thank
to
you,
you.
Amit. Welcome. So today we're going to talk about DevSecOps, the key to successful digital transformation. So Amit, give a brief idea about digital transformations that you have seen and the relevance of DevSecOps in that space.
Sure. So, being a part of a lot of digital transformations when I was with IBM, very large companies and banks. And what we are seeing now is a fundamental transformation that is going on in business. Businesses want to be online, they have new markets, they have new approaches in terms of how they want to get to customers, how they deliver, and even the customers' expectations change. There are completely new markets that open up, spaces that maybe even a couple of years ago that were not open at all. And so there is a very deep need for digital transformation. And so this digital transformation, at the heart of the digital transformation, is a creation of new applications. Many of them are custom to reach to new customers, to deliver to new customers. And the need for these applications, these custom applications, which by the way are changing rapidly, iterating rapidly, because there is so much discovery occurring in the marketplace on an everyday basis. That is creating the need for DevSecOps. So the whole DevSecOps concept has been accelerated, or it has really taken shape because of the digital transformation which businesses require. So that, I think, Rejit, is primarily how the businesses see it. They see DevSecOps as a foundational practice for the digital transformation. But the digital transformation is occurring through brand new applications that reach customers in different ways.
Thanks, Amit. So, when it comes to DevOps versus DevSecOps, can you shed some light into how we reach DevSecOps and what will be the primary differentiators there?
Sure. So I think most of you who know DevOps, I mean, DevOps is a very old concept. It's been around for 30, 40 years. I mean, most of us started off having version control and creating code, and but we used to do it in a traditional manner. A lot of this was through traditional practices. There used to be merges done manually. There used to be, a lot of the testing done manually. Deployments and the creation of full chip, full models were also done manually. Now what has happened is there is an automation layer that is coming below it. So the entire pipeline that starts from Git, which is the repository of your source code, to the validation, to the build using tools like Maven, for example, then further testing, security scanning, and deployment is now fully automated. And that's DevOps. And about 2 or 3 years ago, I think when people spoke about DevOps, they meant the automation of the traditional pipeline for software commit and deployment. But now what has happened is, especially with the advent of containerization, there is a need for ensuring that security scans are done right at build before deployment. So that's been a fairly transformative change, and I think containers have actually made this very, very important and critical. So with that piece, with those two pieces coming together, DevOps became DevSecOps. So DevSecOps is really the insertion of security everywhere in the software pipeline, right from code, commit, through validation, through builds, through deployment. The expectation is now that at every stage there is going to be a need for a security check. And containers specifically are scanned for vulnerabilities before they are deployed, because the fundamental problems is that when containers are built, as you all know, containers are self-sufficient. The entire package is built with the runtime libraries. You're going to go out there and obtain libraries and pieces of code that you have never known before. You don't even know that it is packaged along with your software code. So if there is a vulnerability in some library somewhere that you're not aware of, you could be inadvertently introducing a fairly large gap in your deployment, and that's now no longer acceptable. So this is how the advances in containers, which by the way is great. I mean, containers are great for DevOps. the, the advent of containers, the sophistication of containers has made security scanning vital to DevOps, and that's how security and DevOps have started converging. That's why it is now known as DevSecOps.
Okay. So let's look at the different aspects, of the DevOps or DevSecOps pipeline. So can you kind of take us through the different aspects here?
Sure. I think very quickly, application developer starts with coding, and he's going to probably start with a code that was already existing. He's probably going to make some changes to it. So there is a source control. Git is one of the most popular repositories, but Bitbucket is also equally popular, and Git has several different versions to it. Now, once the code is being checked into the repository, then you have to go through a build. You actually do a build, which is also specific to the kind of code that you've written, whether it is Node.js, whether it is React, whether it's Ruby on Rails, whether it's Python. And so there's different build modules that come into play. Once this is done, this is where the security piece comes in. This is where the code is scanned, the container, the package is scanned for vulnerabilities. And if vulnerabilities are found, then the build is rejected, and the software developer has to go fix it. And occasionally that requires changes to code. Once the scan is done, then there is testing to be done. Testing in itself is a fairly major chunk. We could have a complete discussion on testing, but regression testing is done at this point of time, and the code is basically and ensures that it meets the minimum quality standards. Once that is done, then there might be an approval process, but if this is a dev stage environment, then it just goes directly into the dev stage environment and it just gets deployed. Um, and once it is deployed, then it is ready for use, whether it's dev, whether it's pre-production, whether it's production. It might be multiple sort of environments, and there might be the approval process and the promotion process could be fairly complicated. So this is basically the pipeline. Rajat, what I kind of wanted to ask you is, tell me a little bit about what kinds of, I've heard about YAML files and manifest files which are needed at various stages. Can you shed some light on it? What kinds of files are required? What expertise is required to build it? And how do these things connect with each other? What is the customization that is needed? That's an area that I've always been interested and fascinated with.
Sure, Amit. So when it comes to, I mean, you kind of covered the fundamentals, right? It's basically automate end to end. And if you look at this slide here, right, so you can see that the end to end process is connected. Now you have when you're automating it, the idea is to make sure that after each step it kind of automatically flows to the next step. And as we are going through the steps, there is sufficient visibility available to the stakeholders, right? For example, for the developers, the auditors, the security engineers. So in order to actually build this pipe, I'm going to switch to another slide. So there are popular tools that you could use, open source and licensed, in each one of these steps, right? Now, in order for us to connect this together, a very popular model that we even Jenkins uses it, and most of the other pipelines use it as well. It's a declarative mechanism. That means in order for you to, when you're having so many tools, we want to reduce the amount of scripting. Instead, leverage the open source tool to its maximum, and then connect them together using a declarative model. And you want to choose a platform that is capable of doing that. That means if I'm committing the code to GitHub, and from GitHub I want to go to Maven and or Gradle, or a Node npm build, I should be able to declare that in my as part of my source control system and say, here is my assets that you need to scan. This is here is the build script that you need to run. All that need to be embedded somewhere. So the preferred method nowadays is to use a file, a declarative file. For example, if you're using Jenkins, it'd be Jenkins file. And in our implementation of APPZ, we use an APPZ YAML, right? So what that does is it basically understands as the developer codes and commits that changes or the project into a Git repository. The system will be able to read the YAML and understand how the pipeline need to be configured. So, for example, if it's a Maven build, it needs to know from the YAML file that I need to trigger a Maven build now, and from the Maven post Maven, what comes out of it. So it will then configure the next scanner. For example, there are if you look at different enterprises, SonarQube is very common for scanning, for quad quality and security checks. And there are other security tools also could be in the pipeline, like Aquasec is one of them. So in order to push the right assets to these scanners, the declarative YAML is very important, right? Now, testing also, in unit testing and functional testing could be integrated to the pipeline. So it needs to know what the endpoints are, what credentials to use, or what functionality or flow to use. These could be put in the YAML file as well. Then comes the approval process. So, for example, it needs to know, as the pipeline needs to know, which target environment is going. If it's dev, the controls might be less. They might not need an approval. The developer simply looks at the previous steps reports and deploys it. But when it goes to higher environments like QA or production, there might be approvals required. So here, integration with Jira or ServiceNow is required. And a lot of people nowadays use Git using Git flow. They use Git flow for approvals. But all these things need to be declared somewhere or defined somewhere. So a YAML-based model is what we prefer, and a lot of systems are preferring that nowadays. Now, when it comes to deployment, now things are getting even more complicated. Like, for example, if it comes to Kubernetes, a lot of deployments are happening into Kubernetes now. It is gaining a lot of momentum. So when it's deployed into Kubernetes, creating and managing the Kubernetes manifest itself, it's a very time-consuming process. And also, Kubernetes being a moving target with multiple versions coming out every year, the YAML need to be up to date. So there again, you want to be able to read the intent of the developer from a YAML file and generate the Kubernetes manifest on the fly, right? And this could even be, it's good true for Terraform and AWS CloudFormation templates as well, because there are parameters that you need to pass to a Terraform or a CloudFormation that need to come from the developer, and that could be put in a YAML file as well. So a pipeline that can in summary, the pipeline itself will be generated and configured using a declarative model, which makes the maintenance and the upkeep of the pipeline itself very easy.
So, Rejith, in each of these, you spoke about the manifest for Kubernetes, for Maven. Is this a fairly complex and rigorous process? I mean, are there a lot of different parameters and configurations that you have to carefully create so that the builds occur? And is this really very custom based on the organization's need? Can you shed some light on that, please?
Sure. So when it comes to Kubernetes, for example, right, the YAML file could be really complex. The YAML file should start with the workload itself, on how the workload need to be configured, to how the network need to be configured, how the load balancer need to be configured. All that is going into these YAML files. So the YAML files could be multiple of them in order for a single deployment to happen. And it's also complex. And it needs a Kubernetes engineer to actually manage it and create and manage it, right? So a pipeline that is capable of generating those Kubernetes manifest files. I mean, I'm taking Kubernetes as an example here. Similar, complexity is there in Terraform or AWS CloudFormation as well. So the developers who are actually coding these applications, they might not have the skills to manage the Kubernetes manifest or the CloudFormation templates. And that is a common issue that we are seeing across the board when we approach customers. They tend to give the opportunity for the developer to start the YAML creation, which because of the complexity, that YAML quickly becomes outdated. There could be security vulnerabilities. There could be issues with configuration, scaling issues, resilience issues. So it's better to have a system and a process where you have a separate team either managing those, that's extra investment, or a tool that can actually generate and manage it for you. Did that make sense?
Yes, absolutely. I mean, it absolutely does make sense. And Rejith, one of the things that I wanted to tee off is when we began our DevOps journey, it was with one of the US-based multinationals, and we started going down the journey. And it initially we got a lot of success, and we had a situation where we were rapidly able to build the pipeline, in the declarative form, the builds as well as the scanning tool. And the deployment. And we were able to get this working fairly rapidly. But I think that what happened is that as soon as you start moving into a variety of environments and a variety of different application types, and different, and sometimes one scan tool is not sufficient because it may have its strengths and another scan tool may have its own strengths. So you a lot of companies want to have multiple scanning tools, multiple security tools to validate that they are not introducing vulnerability. So when we started building the DevOps pipeline, our early successes led us to believe that this was a simple process. As we kept going further and further into this journey, we started realizing that we needed to have a lot of different skills. We had to bring a lot of different skills to the table. And even after you brought a lot of different skills to the table, there were challenges. So the problem multiplicated very quickly and in DevOps. It was still a successful project, but at the end of the day, I think we realized that it requires a lot of different skill sets and it requires a lot of work. It not as easy as it sounds. Like you said, you need to make sure that you have individuals who know different skill sets in the different pipe stages.
That's right. Thank you. And let's move on to the next slide here. So when it comes to security, right? I mean, if we are talking about security, that DevSecOps, that's the key here. We are trying to incorporate security into every step from day one. So can you shed some light into from an application development standpoint and deployment? What are the different areas where we need to focus in when it comes to security or injecting security?
Yeah. Yeah, and security is really a very, very large area, and I don't know whether we'll be able to cover it, and it would probably not do justice. But there are obviously areas in terms of security. I mean, especially when you are looking at containers, uh, we better be making sure that you're scanning the container package for any vulnerabilities before you deploy it. Simply because, like I said, when you're linking up all your runtime files, you don't really know whether any of them could have been exposed or could have been vulnerable in the first place. So you don't always know everything that goes into the container. You know your source code, but there's a lot of other pieces that go into the container. So that's a very critical piece, and that scanning is very critical. Aside from that, you have to run a lot of tests. There's a lot of security testing that you have to do for vulnerability, and the tools there give you wizards and they allow you to tune your testing so that your analysis is it's you can explore it and you can ensure that the various tools are geared towards testing as many vulnerabilities as possible. There's a lot of different areas in terms of security testing besides the ones I just mentioned. Also want to make sure that your Git is not corrupted. Also want to make sure that you also have updates for your tools, and you have all the latest and greatest patches. So it's a blue ocean out there as far as security is concerned. But I think that it's a good development in the DevSecOps pipeline that now we have a lot of tools that are available for doing security testing right off the bat, and these can be picked up and integrated into the pipeline. So, Rejith, can you maybe perhaps also spend a little bit of time in terms of telling us a little bit about what has always fascinated me is especially how these security tools integrate with the rest of the pipeline. So, can you do a little deep dive into how these security tools are integrated with the rest of the pipeline and how is this testing occurring in the DevOps pipeline?
Sure. So when it comes to integrating security with the pipeline, right? So there are two aspects to it, right? Number one, the pipeline itself. There are various steps that we talked about earlier. We want to be able to get visibility, and security should be part of every step, right? For example, one important point you made earlier was, when it comes to containers, as soon as the container image is built, you want to scan it and produce a result, and let the process stop there if there are critical issues. So the developer can fix it, trigger the containerization again, and then deploy. So number one, during the build process, the scanning is important. Now, when it comes to the deployment aspect, that is at the, I'm going back to that same slide here. So if you look at the deploy here, over here, we want to make sure that the configuration is accurate. Like, for example, there are industry standard practices for Kubernetes YAMLs on how it can be secured, how a workload need to be secured in a Kubernetes environment, how the network need to be configured properly in a Kubernetes environment. There are similar guidelines for AWS, Azure, and Google Cloud services, as well as VMs. So it's important that at the time of deployment, the YAML files and the CLI API calls generated are actually instructing the underlying infrastructure to properly secure the deployment. So that's part of the pipeline as well. Now, once it is up and running, there has to be a constant monitoring where we need to watch the deployment, the workloads running, and the network to make sure that the systems are the configuration hasn't changed, right? Or if when, let's say, a new vulnerability that popped up that was not part of the build, it was not discovered during the build time. Now, a new signature might pop up that will tell us, hey, here is a vulnerability that just, we just figured out recently. And now you want to make sure that, even if the pipeline is not active, the runtime need to be scanned. So the way the pipeline need to be configured is that once the workloads are running, there has to be scanners pointing to these workloads and the configuration to make sure that even when older versions of this application is running, we are constantly scanning it to make sure that the latest signatures of vulnerabilities are monitored. And if it occurs, an alert should be generated so that the developers or the operations can re-trigger a deployment so that it will go through the pipeline again and refreshes the vulnerable component. So, and I'll quickly show you, the architecture that we follow. This is our platform. The way we implemented this is full end-to-end automation. So if you look at the right-hand side, we have the different environments, and on the left-hand side, we have the different stakeholders, right? So we have the stack engineers who actually manage the image templates and Docker files and the YAML files, YAML file templates. They themselves, they will use a Git-based model so that its full visibility is there in terms of making sure that there is peer reviews and there are tests done as they are injecting the templates or the automation scripts into the system. And then developers and operations, they are going to use YAML-based manifests to trigger their intent. Like, for example, if they want to deploy an application, if they want to create a load balancer or change a load balancer or switch from blue deployment to green deployment, all those are defined as part of a YAML file and committed to the Git. Now, from there, a GitOps engine will pick up these YAML file changes and the automation file changes. It will pull, it will validate, it will build the artifacts, scan it, and push it into a repo. Now, this repo is constantly scanned as well. So that goes to my earlier point. Once the build time scan is done, the image is sitting in a repo, and you want to make sure that that repo is constantly scanned. And one good example of that is an ECR scan. If you're using AWS, you want to make sure that all your images are pushed into ECR and enable the ECR scanner so that the ECR scanner will constantly scan your images and let you know when there is a problem, right? Now, once the images are available, you get approvals for higher environments through using a workflow manager. It could be Jira or ServiceNow. And if for non-production environments, it goes straight to deployment. Now here, the deployment manager's job is to make sure that it uses the right configuration to generate the APIs and the YAMLs required for the underlying infrastructure to host this application in a secure way. So that's done by the deployment manager, and deployment manager would then deploy that into the target environment. Now, it is very important, once it is running there is security scanners pointing to that configuration as well. And there is sufficient visibility in terms of application logs, application performance metrics, and security logs. Now that observability is very important, and that observability will capture any changes, any logs, any activity, any configuration changes, and keep on scanning and alerting the engineers if there are issues. So this is a model that we follow in most implementations, and it has been very successful. So here the idea is automate end to end.
Yeah, and it seems to me, Rejith, that DevOps has really come a long way. From starting with Jenkins and trying to create your own pipeline and writing your own manifest to the point that you already have a pre-integrated platform that you can start with. So there's a lot of stuff that is already available and ready, including security integration, including deployment into different target environments. So, and you probably also have templates for the normal builds in Maven and Ant and so on. So it's come a long way. Can you maybe just take a minute or two and tell us a little bit more? I mean, both futuristically as well as what is present. Obviously AppZ is at the very cutting edge in terms of integration and simplifying the work for our clients. What else do you see coming down the road, as well as where do you see very interesting ideas coming up? I mean, obviously Docker and Kubernetes has changed the world. Are there other things like this in the DevOps world that are rapidly changing the way we are working and we'll be working in the future, Rajat?
It's a good question. Thanks, Amit. So going back to the diagram, right? So if you look at the various components here, right? Automating end to end with in a reactive mode, with all the scanners in place, and having a GitOps based model definitely works. It helps, and it also reduces the amount of manual effort in deploying and managing your components. But if you look at the trend, right? Number one, of course, there are new standards coming out in containers, how to manage containers, how to configure them, and also how to manage the secrets, how to manage the network configuration, the load balancing. There are, of course, standards coming out there, and we're making a lot of improvements as an industry. And if you look at various open source projects, including Kubernetes and Docker, they have made a lot of progress in that space. Now, when it comes to observability, and there are several tools out there that are really gives all the visibility that you need in terms of resource utilization, security logs, and also from application logs. So the idea here is when your workloads are running in an environment, you really want to make sure that it is the operation model that you're using is a low touch model.
Mm.
Now that trend is happening where the cloud is becoming more and more an appliance. So if you look at the stakeholders on the left here, right, they want to use cloud as an appliance while they invest all the time in creating IP and business value for their customers. So as the standardization is improving and the automation is improving, the cloud is becoming more and more an appliance where the developers are coming in and saying, hey, they will sit with the business team, take the input, go code it, commit, and that commit gets automatically deployed. So now that automation, of course, it's efficient. It also very repeatable. So that means your time to market is going to get better, and because of the complete infrastructure as code and policy as code and configuration as code model that we all use today, including this approach that we are taking, the advantage you get is, let's say you want to try out something. Like for example, hey, I want to bring up a new version of the application. It can happen in minutes, right? Several of our customers do that today. If they want to try something new, they can try it in minutes, and once they like it, they can use a blue-green approach to say, hey, I'm going to start sending 10% of my workload to the new code, or maybe a particular client, or maybe a few clients to the new code. That is possible now, right? Now, when it comes to operations, there is a lot happening in the low-touch operation space. That is, Once this observability data is collected, and now you can now apply AI and machine learning on it. So that means your alert generation, self-healing, and auto scaling can be improved by means of using machine learning. And in our platform, we are starting to do that, right? So there is, once the data is collected over a period of time, you can actually create models where you can say, hey, these are the possible scenarios that can lead to a downtime. And
Mm,
we can predict that and make adjustments earlier on, rather than waiting for an incident to happen.
yeah, very true. And I think Kubernetes is definitely going to help in terms of the way Kubernetes is structured, where you, if, for example, a container goes down, it's able to immediately bring up another one. So it is resilient by nature, and Kubernetes is definitely going in that direction. Um, I had a couple of thoughts, Rejith, just as we start winding up, right? I think we went through a very interesting discussion on DevSecOps today, and just my thoughts. This is foundational as I see this. I think that two areas where this is critical. One is that those businesses that are pursuing a digital strategy, so they are creating new applications to reach to new customers, new markets, new ways to deliver products. Clearly, that's one of them. Another one is app modernization. So a lot of customers, one of our customers has been talking with us with respect to their applications. They're 20-year-old applications, and they want to refactor them. They want to convert them into microservices. They want to start using the benefits of DevSecOps to create several microservices that now functionally present a richer value proposition for their ecosystem. So both these cases, and both businesses are going down both of them, and some more in one direction, some more in the other direction, but there is both of these happening. So I think DevSecOps becomes fairly foundational over here. And there is a real need for businesses and even infrastructure teams to start going up the value, up the stack, not focus so much on infrastructure, but use technologies like you have, which are pre-integrated, and focus really much more on the content versus, the infrastructure pieces, because that's no longer interesting to business. So those were some of my closing thoughts. Rejit, what about you? Anything that you would like to sort of reflect on?
So one point I wanted to bring up, or one, so when it comes to implementing this, we talked about one implementation, that's ours, but Amit, I thought we should also touch on the key challenges that people are facing today, right? So I thought we had a quick slide set up, right? So if you could kind of touch on this, right? This is real, we have seen it in so many places, so many customers
Yes.
go through this. So if you could kind of go, quickly go through this, I think that could be our last part.
Sure. Sure. So I started by giving you an example of a US based company that we started doing DevOps for, and we achieved a lot of early successes. But as we got more into production and a variety of different applications, and the requirements became far more stringent. So, what I see is that um, there are so many different skills that you need, and acquisition of the skills in a marketplace like ours, which is very hot, is very difficult. And often projects get delayed because you don't have specific skills. You can't procure them. Not every single small and medium business can procure all the required skills in the pipeline that we talked about. And security is another key area. So because it is so vital to DevOps, DevSecOps, you have to get security experts. Again, it's non-trivial, and you have to produce and review a lot of manifests and templates. All these are intensive, intellectually intensive tasks, and it can be misleading. That is the technical aspect. Then, aside from that, there are cultural challenges with respect to adopting new technologies. There is also, for example, the need for senior leadership to drive change management, because people get comfortable in the traditional way that they do software development and software deployment. But DevSecOps changes it all. It changes the way that you commit your code, that you deploy, you test your code, you deploy your code. So there are twin challenges. One, a set of challenges associated with primarily integration, and security, and the need for diverse and specialized skill sets to create a pipeline for reasonably robust and sophisticated pipeline for your business. That is a challenge in itself, and it's often underrated. And the other part is the entire cultural challenge with respect to adoption. Both these make it difficult. So DevSecOps, if you have a pre-integrated platform like yours, for example, at least the technical portion of the challenge becomes easier, much easier for the organization, especially small and medium businesses, to really focus on the content, which is really the value proposition that they have.
All right. Thank you, Amit. I think it was a great conversation. So, when it comes to implementation, I know, as a closing comment, right? See, automation is the key, and a declarative approach is what a lot of the developers would like to have. They see that the appliance model. You want to make the cloud and or your infrastructure look like an appliance, and the key to achieve that is to have an integrated pipeline where the developers simply show their intent in form of a YAML, and the pipeline would take that and reconfigure itself to achieve the developer wants. Now, this automated mode, one advantage is also that as a company, as an enterprise, you now can configure the platform in the way you need it. When the developer says, I need a load balance or I need to run something, the pipeline can put all the security measures in place and create that landing zone for that application. So that is very important. So then the integrity of the landing zone, integrity of the workloads running can be kept in a much really secure way, and keep it intact, because everything is automated. It's repeatable, and the result of that will be, developers gets what they want, but the enterprise gets what they want as well, because the pipeline itself is managed by a team that enforces all the required compliance and audit requirements and security requirements as part of the pipeline. And it is all baked into the pipeline rather than developers making choices. So that is key. So our platform, that's what we offer as an integrated platform. So there are other tools. We also touched on a bunch of other tools. There are tons of material on our website as well as CMSIT's website, where you can learn more about this. So please do reach out to us if you have any questions. We'll be happy to answer your questions. And thanks again for joining today. I think we had great attendance. And Amit, thank you. It was a great conversation. Thank you very much.
Thank you, Rejith. Thank you, everybody, for attending.
Thank you.